My name is Sanne Muis and I work at Deltares. We're working on a Copernicus climate change service where we develop global projections of extreme sea levels under climate change. This project is led by Deltares with contributions from GBA, VU Amsterdam and IHE Delft. And in this video, I would like to explain a bit more about the background of the project and the dataset that we have developed. So first, why develop this dataset? As many of you are aware, the risk of coastal flooding will increase rapidly in the next few decades. This is in part due to rising sea levels as a result of global warming and the melting of ice sheets, but also due to change in extreme weather, which can impact the frequency and severity of storm surges and consequently coastal flooding. An accurate understanding of how the probabilities of extremes may change under climate change is needed in order to take adequate measures and protect our coast. With this in mind, we have developed a pan-European dataset in the previous CDS contract. This dataset, openly available at the Climate Data Store, consists of time series of tides, storm surges, total water levels, and mean sea level. For this, we have used the Global Tide and Surge model, which has a high accuracy and an unprecedented coastal resolution of 1.25 kilometers. In addition to the time series, we've computed various indicators, such as tidal levels, percentiles, and return periods. And these indicators can be used to inform various coastal sectors on how coastal extremes may change under future climate change. To easily browse through our data, there's also an application built on top of this dataset. And in this application, users can select different indicators which will be visualized on the map. Here you can see an example of the average tidal range for a 30-year period. Users can also select individual locations or taking the next step. And in a new contract, we've disabled global multi-model projections from 1950 to 2050. In comparison to the previous contract, there are three main innovations. First, we increase the spatial coverage from European to global. Second, we go from a single CMAP5 model to a multi-model ensemble for CMAP6 models. The key advantage of the CMAP6 models is that they have sufficient resolution to resolve extreme weathers, such as tropical cyclones, and they just give a better precision. Moreover, by using a multi-model approach, we can much better characterize the uncertainty that's associated with future climate projections. And finally, we improved the extreme value statistics, and we moved away from an annual maximum to a peak surfer threshold method. Altogether, these innovations constitute a major step forward compared to the previous contract, and we believe this dataset will help to better plan for the future. Here I would highlight some first results. The first results show that there are strong spatial biases for the historical simulations, which is one of the reasons why we need a multi-model approach. When we analyze changes compared from the historic to the future period, we see that storm surges may both increase and decrease depending on the location and depending on the model. In general, there's little intermodal agreement, which highlights again the uncertainties associated with future projections. We foresee various applications of this dataset. For example, the return periods can be used for the global mapping of coastal flooding, which can provide insights in what are the hotspots of the world where coastal flooding may increase. As part of the previous CDS contract, there were also various use cases. Here I will highlight two of them, which could be updated using the new dataset. One of the use cases was to see the impact of water level changes on port operations. It highlights that ports may become more accessible due to the changes in water level. So it's actually a benefit of climate change. The other use case was near Copenhagen and to see how the city could be protected against flooding. It showed that the storm surge barrier would have to close from once a year in present day climate to 5 times a year by the end of the century. This is relevant information that can be useful for stakeholders to make changes to their coastal management planning. So that was a short summary of our new dataset. We'll be around at the virtual market booth and feel free to ask questions and to reach out to us if you want to know more. Thanks.